Students, I am coming within 2 minutes. Please wait. स्टूडेंट्स एक 2 मिनट वेट करो, फैकल्टी थोड़ा सा ट्रैफिक में अटक गया, कहते हो ना, आ रहा, ठीक है। एक 2 मिनट, जस्ट 2 मिनट्स ओनली। Yeah, please wait for 2 minutes. Faculty will come. Okay. जब तक yeah, please wait for 2 minutes. Faculty is coming. Okay. Today physics class is there. Sir is coming. Please wait. Just wait. जस्ट वेट फॉर 2 मिनट्स, सर इज ऑन द वे। कुछ ट्रैफिक में फंस गया कहते हैं, आ रहा, जस्ट वेट, प्लीज वेट। जब तक वो सारा है तक विल टेक वन टॉपिक जो मैं कल लेना चाह रहा था, कल जो पीडीएफ डाउनलोड नहीं हुआ। ओके, सो आर यू रेडी? शैल वी टेक उन्होंने आए तक, फिजिक्स आ रहा है तक? इफ यू एग्री आई विल टेक, राइट? ओके। सो दिस इज ए वेरी ब्यूटीफुल टॉपिक एंड ये जो आंसर आप चाहे कोई भी कॉम्पिटेटिव एग्जाम्स लिखिए, डेफिनेटली यू विल हैव क्वेश्चंस फ्रॉम दिस, राइट? ओके, डेफिनेटली यू विल हैव क्वेश्चंस फ्रॉम दिस, राइट? ओके, तो वो है आपका ब्लड रिलेशंस, राइट? ओके, सो ब्लड रिलेशंस के बारे में थोड़ा सा इंट्रोडक्शन देख लेते हैं हम लोग, राइट? ओके, तो यहाँ से मैं पेन ले लेता हूँ, ठीक है? विच एवर एग्जाम्स यू आर राइटिंग, डेफिनेटली यू विल हैव क्वेश्चंस फ्रॉम ब्लड रिलेशन। आपको पक्का एक क्वेश्चन आएगा ब्लड रिलेशंस, राइट? ओके, सो ये जो ब्लड रिलेशन टॉपिक है, ठीक है, ये जो ब्लड रिलेशन टॉपिक है आपको, ओके, you will be having three types of questions here. One is pointing to a photograph, ये क्वेश्चन आता, राइट? पॉइंटिंग टू ए फोटोग्राफ, टू ए फोटोग्राफ, ये क्वेश्चन आता, राइट? ओके, नेक्स्ट एक नेक्स्ट जो क्वेश्चन आता आपको, थ्री थ्री मॉडल्स है इसमें, बेटर मैं डायरेक्टली आपको मॉडल से बता देता हूँ, ठीक है? राइट, ये एक मॉडल है और इसमें इंटरेस्टिंग तो ये रहता आपका, सर अच्छा रहा निकल जाता चेयर, ओके ओके, राइट राइट। ये एक मॉडल है और एक मजेदार बात बताता हूँ आपको कि खासतौर से ब्लड रिलेशन में अगर ऐसे क्वेश्चंस अगर आपको आ गए तो समझो यू आर वेरी लकी, राइट? 4 सेकंड्स में आंसर आता है इसका, खाली 4 सेकंड। ये मैं आपको लेकिन बेसिक से ट्रेन करता हूँ इसको, राइट? ओके, इसको बेसिक से ट्रेन करता हूँ। हालांकि अगर कोई आप कॉर्पोरेट टाइप की आप इसमें अगर आप कुछ अगर इससे ये इसको क्या बोलते हैं, दे टीच, आपको काफी मुश्किल तरीके से उसको समझाएंगे, लेकिन देखो मैं इसको कैसे सिंपली समझाता हूँ, राइट? ओके, क्वेश्चन क्या पूछा है यहाँ पे, इतना सब लंबा चौड़ा कुछ भी पढ़ने की जरूरत नहीं। कभी भी अगर ये मॉडल क्वेश्चन आ गया, इफ a plus b is equal to a is the mother of b, कुछ ऐसा, राइट?
Sir, I can't hear your voice. Sir, I am unable to hear your voice, sir.
Excuse me, sir. Sir, you are in mute, sir. We are not audible your voice. You are on mute, sir.
స్టార్టింగ్ నుంచి చూస్తున్నా
సార్ నాకు తెలియదు సార్ మళ్ళీ మొదలు నాకు తెలియదు సార్ నాకు మ్యూట్ లో ఉంది ఎవరో ఏదో చెప్పడానికి ట్రై చేస్తున్నా నాకు వినిపిస్తుంది మెసేజ్ సార్
ఇక్కడ ఉన్నాయి యూ హ్యావ్ టు చెక్ ఇట్ చెక్ చేస్తూ ఉండాలి.
ఓకే ఎక్కడ మెసేజ్ ఇక్కడ
ఉంటాయి ఏం ఐడియా లేదా మీకు?
ఇదా ఇదా
ఇక్కడ ఉంటాయి పక్కన చూడండి
ఇదా ఇదా
టెక్ సెకండ్ ఇవి సార్ ఇప్పుడు ఇది ఆన్ ఇక్కడ సైడ్ లో ఉంటాయి ఇక్కడ చెక్ చేస్తూ ఉండాలి
మరి స్టార్ట్ చేయాలా? Okay, good morning to all. And in this topic, in this class, we are going to start the other topic, new topic. And most of the students are unable to hear my voice, and it was in mute. So technically, I don't know how to operate this system, this new system, because of that reason. I taught in online, but this system is very different and something difficult for me. And it was on mute. I could not see that. Even our computer operator also could not tell me. So I'm sorry. Anyhow, I'm teaching from the beginning, and we are starting in this chapter sound. In this chapter, we are going to start sound. Sound. A new topic we are going to start. What is sound? Sound is a form of energy. It's a form of energy which provides a sensation of hearing. Sound is a form of energy, provides a sensation of hearing. And according to law of conservation of energy, the energy doesn't have particular form. It has so many forms. One of the forms is sound, which provides the sensation of hearing. And sound can be produced only from a vibrating object. Vibration is compulsory for producing the sound. Only from a vibrating object. Unless the object vibrates, the sound cannot be produced. Suppose, let us consider an iron rod. Let us consider an iron rod. If you take an iron rod, then if it drop from certain height, it vibrates. As long as it vibrates, it can produce the sound. So sound can be produced only from a vibrating object. Unless the object vibrates, the sound cannot be produced. Unless the object vibrates, the sound cannot be produced. So if we drop the iron rod from certain height, it vibrates. As long as it vibrates, it can produce the sound. So after dropping, it will produce a sound. Then after dropping, if we catch it, we are stopping the vibrations so that it can vibrate. Sound can be stopped. Similarly, if you ring the cycle bell, it vibrates. As long as it vibrates, it can produce the sound. After ringing, if we keep the hand on the bell, it stops the sound. It stops the sound. Therefore, it stops vibrating. So it stops the sound. Why? Because it is stopping vibrating. If you won't keep the hand on the bell, it produces sound for few more seconds. Why? Because it goes on vibrating. Therefore, sound can be produced only from a vibrating object. Unless the object vibrates, the sound cannot be produced. Therefore, sound can be produced only from a vibrating object. Unless the object vibrates, the sound cannot be produced. So, similarly, while we are talking, our muscles can vibrate. Then, afterwards, after producing the sound travels in the form of wave. Sound travels in the form of wave. and any medium is necessary for the propagation of sound. It doesn't travel through vacuum. Suppose if two astronauts talk to each other, medium is necessary for the propagation of sound. Any material medium is necessary for propagation of sound. Necessary for the propagation of sound. That means it doesn't travel through vacuum. Sound doesn't travel through vacuum. Sound cannot pass through vacuum. So, and sound can sound can propagate in the form of wave. Sound can propagate in the form of wave. Therefore, suppose if we take hacksaw blade or shaving blade, if you insert in the blade, slit of the table, if you vibrate, after vibrating, it can produce a sound and it travels in the form of wave, so that it travels in the form of wave through the atmosphere. Atmosphere is the medium. It reaches our eardrum so that we can hear the sound. So after producing the sound from this thing, now it can propagate to the medium atmosphere. Now it reaches our eardrum so that our eardrum vibrates to the sound. Then for each and every sound, how far our eardrum vibrates. For each and every sound, our eardrum vibrates for a minimum time period of 1/10 second. It vibrates for a minimum time period of 1/10 second. Vibrates for a minimum time period of 1/10 second. Divide 1 second into 10 equal parts. Whatever we get, that time it can vibrate even for that time period. 1/10 second. That is also written as 0.1 second. That is also written as 0.1 second. 0.1 second. 0.1 second it vibrates. For a minimum time period of 0.1 second it vibrates. 0.1 second. For each and every sound, our eardrum vibrates for a minimum time period of 1/10 seconds or 0.1 second. So what is 1 second? If you watch wall clock, then the time interval between two motions of the seconds hand is known as 1 second. 1 second. If that 1 second is divided into 10 equal parts, each part is known as 1/10 second or 0.1 second. It's a very less time. Therefore, it vibrates even for that time period. Therefore, the minimum time interval for which our eardrum vibrates for each and every sound is 1/10 second. Therefore, this is known as persistence of hearing. This 1/10 second is known as persistence of hearing. This is known as persistence of hearing. Persistence of hearing. Why? Because for each and every sound, our eardrum vibrates for a minimum time period of 1/10 seconds. Whenever the object is vibrating for the sound, if another sound can be produced within 0.1 second, that means two sounds are produced within 0.1 second, we miss the second sound. Why? Because for first sound itself, the eardrum vibrates for a minimum time period of 1/10 second or 0.1 second. For the first sound itself, it vibrates for a minimum time period of 1/10 second or 0.1 second. Therefore, our eardrum should vibrate. Whenever it is vibrating for the first sound, if the second sound approaches, we can't hear that sound. Why? Because for the first sound itself, our eardrum vibrates for 1/10 second. It should come after 0.1 second. Second sound should come after 0.1 second. Then only it can vibrate for the second sound. Then only we can hear the other sound. If other sound comes within 0.1 second, then it can't vibrate for the second sound. That's why we miss the second sound. Therefore, the minimum time interval required for hearing two sounds clearly is 1/10 second or 0.1 second. What is the minimum time interval required for hearing two sounds clearly? So for hearing two sounds clearly, that is 1/10 second or 0.1 second is required. For hearing two sounds clearly, 1/10 second or 0.1 second is required. 0.1 second is required for hearing two sounds clearly. Then human beings can hear maximum how many sounds per second? Human beings can hear maximum 10 sounds per second. We can't hear more than 10 sounds per second. We can't hear. We can't hear more than 10 sounds per second. We human beings can hear maximum 10 sounds per second. We can't hear more than 10 sounds per second. More than 10 seconds per second. Why? Because in 1 second, how many 1 by 10 seconds will be there? In 1 second, there will be 10 1 by 10 seconds will be there. 1 by 10 plus 1 by 10 plus 1 by 10 plus 1 by 10. How many are there in 1 second? There will be 10. 10 1 by 10 seconds will be there. So that is 10 plus 10 plus 10 is nothing but that is equal to 1. 10 times 1 by 10 plus 1 by 10 plus 1 by 10. That means for each and every sound, our eardrum vibrates 1 by 10 seconds. Therefore, human beings can hear maximum 10 sounds per second. Or else, in 1 hour, how many 1/4 hours will be there? In 1 hour, there will be 1/4 hours will be 4. Why? Because 1 by 4 plus 1 by 4 plus 1 by 4. 4 times is nothing but 1. In 1 hour, 1/4 hours will be 4. Similarly, in 1 hour, how many half an hours will be there? Half an hours are nothing but 1 by 2 hours. 2 will be there. Similarly, in 1 hour, how many 1 by 10 seconds will be there? How many 1 by 10 hours will be there? So, in 1 hour, there will be 10 1 by 10 hours will be there. Similarly, 1 second, there will be 10 1 by 10 seconds will be there. 1 by 10 seconds will be by 10. 1 by 10 seconds will be 10, 1 by 10 seconds will be there. That's why we can't hear more than, that is, we human beings can hear maximum 10 sounds per second. That is 10. 10 1 by 10 seconds will be there in 1 second. Therefore, human beings can hear how many hours in second? That is 10. 10 we can hear. We can't hear more than 10. We hear only maximum 10 sounds per second. We hear maximum 10 sounds per second. We can't hear more than 10 sounds per second. We can hear maximum 10 sounds per second. Okay. Then, so is it okay, students? Any problem? Please respond. Then maximum 10 sounds per second. Then it was given different competitive examinations. What is the minimum time interval required for hearing 2 sounds clearly? It was given SSC, RRB, and also sub-inspector of police. It was given. So maximum we can hear the minimum time interval required. What is the minimum time interval required for hearing 2 sounds clearly? The minimum time interval required for hearing 2 sounds clearly is 1 by 10 seconds. So that is 1 by 10 second or 0.1 second. And also it was given RRB and sub-inspector of police. How many sounds we can hear per second? In 1 second, how many maximum number of seconds we can, maximum number of sounds we can hear? Human beings can hear maximum 10 sounds per second. We can't hear more than 10 sounds per second. Then let us learn about frequency. About frequency. Then let us learn about frequency. Frequency. What is frequency? When an object is under vibrations, the number of vibrations produced per second is called its frequency. Number of vibrations produced per second. Whatever the number of vibrations per second is known as its frequency. Suppose if an object makes 20 vibrations per second, then its frequency is known as 20 hertz. 20. So if it makes 30 vibrations per second, its frequency is 30. If it makes 60 vibrations per second, then it is 60. Then units for frequency is units for frequency. Units for frequency is hertz. hertz. HZ. Units for frequency hertz. In general, the frequency of the object always remains constant. The frequency of the object always remains constant. The frequency of the object cannot be changed. Each and every object has its own frequency called natural frequency. The frequency cannot be changed. Suppose if makes 20 vibrations per second, the object, then it is known as 20 hertz. Its frequency is 20 hertz. What is vibration? When the object is under vibrations, the to and fro motion. Suppose let us slit any object like hacksaw blade or shaving blade. Shaving blade is the slit of the table. Let us strike it. It makes vibrations. The to and fro motion of the object from its mean position is known as vibration. The to and fro motion. Whenever it is moving like that, to and fro motion, then it is known as frequency. The to and fro motion of the object from its mean position is known as frequency. It can move. That is known as frequency. So therefore, it is known as frequency. In general, the frequency, suppose it makes from this extreme position to the other position and again gets back. That is known as one vibration. Like that, if it makes 20 vibrations per second, then its frequency is known as 20 hertz. If it makes 30 vibrations per second, its frequency is known as 30 hertz. Like that. So that the frequency of the object always remains constant. We can conduct an experiment. Take a hacksaw blade, insert in the slit of the table, you strike it. So suppose it makes 12 vibrations per second. Next time you stop it, you strike it with more force. Then it vibrates. Now it makes how many vibrations? 12 vibrations again per second. So if you apply more force, again 12 vibrations per second. Apply less force, 12 vibrations per second. You apply modern force. It is independent of the force of light. Therefore, each and every object has its own frequency called natural frequency. The frequency of the object cannot be changed based on the force of light. You can conduct the experiment. Take best example, cradle. Best example, cradle swing. Now, so you pull it, leave it. Calculate the time for 10 oscillations. One oscillation is from this extreme position to that position, again this position. That is one oscillation. Calculate the time for 10 oscillations, for example. Let it be 3 minutes. Next, you stop it. Now pull more distance, means you are applying more force. Then leave it. Again, for 10 oscillations, it takes the same time. Before, if it is 3 minutes, now also 3 minutes. Now you stop it, you pull only little distance. Now count the time for 10 oscillations, same time. So each and every object has its own frequency called natural frequency. The frequency of the object usually not changed based on the force of light. That's why each and every object has its own frequency called natural frequency. Now, the frequency of the object always remains constant. Now, persistence of hearing, persistence of vision, persistence of vision. Persistence of vision. What is persistence of vision? Then for each and every sound, then for clear visibility of the object, the image of the object should be stay on our retina for minimum 1/16 second. 1/16 second. Then only this is known as persistence of vision. So the objects in the topic sound, I explained that the objects are visible due to reflection of light. Whenever the sound incidents on the object, suppose for visibility of the object is marker, the light should incident on the marker reflected. This reflected light reaches our retina, then the image of the marker can be found on our retina. Then only this marker is visible to us. But the image should stay on our retina for a minimum time period of 1/16 second. Divide 1 second into 16 equal parts. Even that much of time period, it should vibrate. If it is less than that time period, the object is not visible clearly. Therefore, if any object, the image of the object should stay on our retina for a minimum time period of 1/16 second. If it is less than that time period, then the object is not visible to us. Therefore, this is known as persistence of vision. Suppose if you watch either live or on TV, any cricketer, if he makes any boundary like 4 or 6, whenever he strikes the ball, we get a doubt sometimes whether the ball is striking with whether the ball is striking or the bat is striking with the ball or not. We can't get. Why? Because if it vibrates, if it is in touch less than 1/16 second, it's not visible clearly. This is known as persistence of vision. Or if any object makes 16 vibrations per second, more than 16 oscillations per second, any fan it makes, it's not clearly visible. Its frequency or its revolutions per second (RPS) less than 16 revolutions per second if the fan makes, then it is clearly visible to us. So this is known as persistence of vision. Now let us learn the frequency types of sound based on frequency. Okay, let me take some drinking water. So now types of sound based on frequency. Types of sound based on frequency. Sound based on frequency. Based on frequency, the sound will be 3 types. And among them, first one is infrasonic sound. Infrasonic sound. The frequency of the sound is then up to 20 hertz, 0 hertz to 20 hertz. 20 hertz, then the sound is not audible to human beings. Not audible to human beings. Not audible. If any object makes less than 20 vibrations per second, then it is not audible to human beings. But some other living beings can hear this sound, like aquatic living beings can hear. Aquatic living beings. Those which aquatics or aquatic living beings, like fish, tortoise, crocodiles can hear this sound, but we can't hear this sound. Aquatic living beings can hear this sound. And also reptiles can hear this sound. Reptiles. Like snake can hear. Reptiles can hear this sound. Reptiles like snakes, scorpion, lizard can hear this sound. Reptiles. And also even quadrupeds can hear this sound. Those which can move on 4 limbs. Quadrupeds can hear this sound. Those which can move on 4 limbs or 4 legs, like domestic animal beings like cow, buffalo, sheep, goat can hear. Taming animals like cat and dog can hear. And also some other living beings, wild animal beings like lion, elephant, tiger, deer can hear, and also polypets can hear the sound. Polypets, polypets, those which can move more than 4 limbs, more than polypets. Like insects can hear, which has 6 feet or 6 limbs, they can hear. But we human beings cannot hear. That's why if it is less than 20 hertz, if any object makes less than 20 vibrations per second, it is not audible to human beings. And second one is audible range. Audible range. So second one is audible range. Audible range. If the frequency of the sound is 20 hertz to 20,000 hertz, then it is audible to human beings. So therefore, this is audible to human beings. Therefore, it is known as the audible range. Okay, let me take some water, please. This is known as audible range. The frequency of the sound is less than 20 hertz. Is not audible to human beings. That is known as infrasonic sound. If it is 20 to 20,000 hertz, then only it is audible to human beings. Therefore, this is known as audible range. Now, third one is infrasonic sound. Infrasonic sound. Infrasonic sound. What is this infrasonic sound? The frequency of the object is, ultrasonic sound. I'm very sorry, ultrasonic sound. Is ultrasonic sound. Ultrasonic sound. What is ultrasonic sound? If the frequency of the object is more than 20,000 hertz, above 20,000 hertz, then it is not audible to human beings. This is not audible to human beings. Since it is not audible, therefore it is known as ultrasonic sound. The frequency of the sound is more than 20,000 hertz, then it is not audible to human beings. Therefore, it is called the ultrasonic sound. The frequency of the sound is more than 50,000 hertz. It is not audible. Then, is it not audible or any danger by hearing such sound? Most of the students in offline, what they say is it's danger, but no danger, nothing happened. But it's not audible. No danger, but no danger. Why no danger? Why? Because the object is making 20,000 vibrations, means 20,000 vibrations per second, means the object should be very, very lean object. If such object vibrates, no problem, but it's not audible. There is no problem. That's why there is no problem. But it's not audible. It's not audible. Therefore, it is making 20,000 vibrations per second. It's very, very neat, very, very narrow object, thin object, maybe far thinner than a very such object vibrates, no problem. That's why it's not audible. But some other living beings can hear even this ultrasonic sound. Some other suppose some other living beings can hear. Human beings can't hear this ultrasonic sound or infrasonic sound, but some living beings can also hear even infrasonic sound, ultrasonic sound, including our audible range. Suppose then example, dog can hear up to 5 hertz to 50,000 hertz. 5 hertz to 50,000 hertz. Less than 20 hertz also dog can hear. More than 20,000 hertz they can hear. And whatever you hear, they can hear. 20 to 20,000 hertz also they can hear. But we can't hear. Therefore, dog can hear too. So that is less than our frequency and more than our frequency, whatever we hear. And whatever we hear also they can hear. And whatever we can't hear, they can hear. That's why dogs will alert in the night and bark like anything. Then what do you think at that time? What do we see? Say it is overacting the dogs, but it won't overact. Why? Because whatever we can't hear, it can hear. That's why it acts on this point. Then second one is bat or elephant. Bats, mammals, birds, bat. What do we call in Telugu? Gabbilam. Bats or elephants. Elephants can hear and up to 1 lakh. They can hear up to 1 lakh. So that is 0 to 1 lakh hertz they can hear. Hertz they can hear. 0 to 1 lakh hertz. Means less than 20 hertz they can hear, more than 20,000 hertz they can hear, more than dogs they can hear. More than the dogs, more than even human beings they hear, more than human beings they can hear, but we can't hear. So, and one more greatness with these elephants is, and they will make the conversation with their friends and relatives up to 250 kilometers, They will make the conversation with their friends and relatives up to 250 kilometers. 250 kilometers. Suppose let us keep in Hyderabad, Nehru Zoological Park is there. Let us keep some elephants here and take away some more elephants somewhere here. Now here to anywhere up to Telangana, Adilabad, Nizamabad, Karimnagar, Warangal, we can take. Then Nalgonda up to Mahbubnagar, Karnool, and Khammam. These elephants and those elephants will make conversation with each other. How are you? How are our friends? How are our relatives? Like that. They will make the conversation. So therefore, and this is they will make the conversation. And by making such conversation, the elephants will dance like anything. Even though we are nearby them, we can watch their dance and we can see their happiness, and but we can't hear their voice. Why? Because the sound produced more than 20,000 hertz. This 20,000, more than 20,000 hertz is not audible to human beings. Therefore, and that's it. Then velocity of sound we are going to learn. Velocity of sound. Velocity of sound. Velocity of sound. In general, the velocity of sound varies from material to the material. So usually the velocity of sound in solids will be more than the velocity of sound in liquids. And velocity of sound in liquids is more than the velocity of sound in gases. Why is the velocity of sound is more in solids and less in liquids? In solids, the particles are closely concentrated. In liquids, the particles are freely distributed. Since the particles in the solids are closely concentrated, the sound wave velocity will be more. The sound wave velocity will be more. And since the liquids are freely distributed, it takes time in liquids for exchanging the information. It takes time in liquids. And in gases, the particles are too freely distributed. Therefore, the velocity of sound will be too less in gases. Therefore, the velocity of sound will be more in solids, less in liquids, and far less in gases. Then the velocity of sound in some materials will be as following. Velocity, then we are going to no. No, here velocity, material we are going to take. Material, then velocity of sound. In meter per second. Now velocity of sound in air will be that is 333 meter per second, but it varies anywhere between 330 to 340. 330 to 340 meter per second it varies. And water water varies 1435 to 1450 meter per second. Meter per second. Then glass, iron. Iron it varies up to 5,200. 5,200 meter per second. Then steel. It will be 5,500 meter per second. 5,500 it is. And glass, it will be 5,600 meter per second. So 5,600. Now let us make a note here. Note. Note. In general, the velocity of sound changes. Velocity of sound changes. Velocity of sound changes based on the percentage of water vapor in the atmosphere. Water vapor. By increasing water vapor, the velocity of sound increases. Why? Because by increasing the water vapor, the distance between the air molecules will be increased, so that the velocity of sound can be increased. Therefore, the velocity of sound in moisture air will be more than the velocity of sound in dry air. Velocity of sound in moisture air will be more than the velocity of sound in dry air. Velocity of sound in dry air. Velocity of sound in moisture air will be more than the velocity of sound in dry air. Therefore, the velocity of sound increases. The velocity of sound in moisture air will be more than the velocity of sound in dry air. Similarly, the velocity of sound increases with the temperature. Velocity of sound increases with temperature. Why with temperature? Why? Because by increasing the temperature, the percentage of water vapor increases. Last class we have learned that at which temperature the water evaporates. If the question comes, then the water evaporates at any temperature. We have learned. So compare, but if more is the temperature difference, more will be the rate of evaporation. Compared to winter and rain seasons, the water evaporates more in summer. Therefore, by increasing the percentage of water vapor, the velocity of sound can be increased. The velocity of sound can be increased with the temperature. Therefore, the velocity of sound will be increased with the temperature. Velocity of sound will be. Therefore, and also in general, the velocity of sound in third point, velocity of sound in third point, velocity of sound in air will be 333.33 meter per second. For converting into kilometers per hour, we should multiply by 18 by 5 and we will get here 1200 kilometers per hour. 1200 kilometers per hour. So for converting meter per second into kilometers per hour, we should multiply by 18 by 5 so that we can get 18 by 5. So that we can get 1200 kilometers per hour. Therefore, usually the sound travels at the rate of 333.33 meters per second or 1200 kilometers per hour. So in 1 hour it travels 1200 kilometers, or every second it travels 333.33. This is the velocity of sound. Now next point, if the velocity of the object is less than the velocity of sound in air, then it is known as subsonic velocity. Fourth point, if the velocity of the object, fourth point is, if the velocity of velocity of object is less than the velocity of sound, velocity of object, that is, velocity of the object is less than the velocity of the object is velocity of object. Object is less than the velocity of sound in air. Less than the velocity of the object. The velocity of object is less than the velocity of sound. Then it is known as subsonic velocity. Subsonic velocity. The velocity is not subsonic velocity. Means the velocity of object is, if anything is, object is less than the velocity of the object, velocity of sound in air. So that is nothing but this velocity of the object is less than the velocity of the object. This is velocity of sound. Sound means if any object like many object like bike, car, bus, train, airplane, anything, if it travels less than the velocity of sound in air, sound travels at the rate of 333 meters per second or 1200 kilometers per hour. Means if any object travels less than 1200 kilometers per hour, that velocity is known as subsonic velocity. How about our bike velocity? May not be usually not more than 100. If it is more than up to 150 kilometers per hour, that's why it is subsonic, not more than 1200, less than 1200 kilometers per hour. Our bike or car, bus, train, even normal airplanes also don't travel more than 1200 kilometers per hour. That's why that velocity is known as subsonic velocity. If any object travels less than the velocity of sound in air, then it is known as subsonic velocity. Then fifth point is if any object travels more than the velocity of sound in air, then the velocity is known as supersonic velocity. The velocity, if the object travels more than the velocity of sound in air, where v is the velocity of sound in air, which is 333.33 meter per second or 1200 kilometers per hour. Therefore, if any object travels more than the velocity of sound in air, then it is known as supersonic velocity. So, if any object is more than 1200 kilometers per hour, then it is known as supersonic velocity. So, any object, like if anything is there, if it is less, it is subsonic, more supersonic. Then exactly equal, what do we call the object velocity is equal to the velocity of the sound in air, that is 333.33 meter per second or 1200 kilometers per hour. 1200 kilometers per hour. Then it is known as 1 Mach velocity. Sonic velocity or 1 Mach, that is 1 Mach. The velocity of the object is less than the velocity of sound in air, then it is known as subsonic, more supersonic, then exactly equal, it is 1 Mach. Similarly, if the velocity of the object is double, if the velocity of the object is double, then what do we call? Double, it is known as 2 Mach velocity. Double, 2 Mach velocity, that is 2 Mach. The velocity, similarly, triple, 3 Mach velocity. Quadruple, 4 Mach velocity. If any object travels with a velocity of 666.66 meter per second or 2400 kilometers per hour, then it is known as 2 Mach velocity. 3 times 3 Mach velocity. 4 times, that is 999.99 meter per second, 3 times. Or 3600 kilometers per hour, then it is known as 3 Mach. 4 times 4 Mach, 10 times 10 Mach. If anything is there. Similarly, if the velocity of the object is above 5 Mach, or 5 times the velocity of the object, above 5 Mach, take point. the velocity of the object is more than 5 Mach. 5 Mach. If any object travels 5 times more than the velocity of sound in air, then it is known as 5 Mach velocity. If any object travels 5 Mach, then it is known as 5 Mach velocity. It is known as hypersonic velocity. Then it is known as hypersonic velocity. That is hypersonic velocity. If any object travels more than the velocity of sound in air, then it is known as hypersonic velocity. If any object, if anything is there, it is known as hypersonic velocity. Then what are the examples for this supersonic, hypersonic, 1 Mach, 2 Mach, like that? Let us discuss about it. First example, Tejas. Tejas. It is an aircraft. Aircraft means warplane, and it was developed by HAL and NAL. HAL and NAL. Hindustan Aeronautics Limited, National Aeronautics Laboratory, and its velocities V is equal to 1.08 Mach velocity. 1.08 Mach means 1.08 Mach means 1.08 into, that is 1200. 12 8s are 96. Therefore, 1296 kilometers per hour it travels. 1296 kilometers. So 12 8s are 96. Therefore, Tejas is the aircraft developed by HAL and NAL, Hindustan Aeronautics Limited, National Aeronautical Laboratory, and its velocity is 1.08 Mach velocity. Therefore, it travels more than the velocity of sound in air. Sound travels 1200 kilometers per hour, but our Tejas travels 1296 kilometers per hour. Therefore, whenever it is traveling in the air, it is not visible to the normal beings, normal people, even normal army also can't watch it. Why? Because it travels faster than sound. This technology is known as BVRT, stands for Beyond Visual Range Technology. BVRT. This is known as BVRT, Beyond Visual Range Technology. Beyond means out of. Visual range technology means within the visibility range, within the visibility range. Beyond means out of visibility range. That's why whenever it is traveling in the sky, it is not audible to human beings. Suppose if it goes into the Pakistan for attacking or China, it is not audible. It is not visible to those people, those army people. Why? Because unless they hear the sound, they can't look up. No, if they hear the sound, then only they look up. Suppose when do we look in the sky? If we hear the sound. Suppose by the time they hear the sound, it disappears by that time. So why? Because it disappears by that time. Why? Because if any person is there, then if any person is there from us, 333 meters per second. 333 meters away from us. If we clap or shout or whistle or fire with a gun, he responds after 1 second. Why? Because he is at a distance of 333 meters. So for reaching the sound to 333 meters, it takes 1 second. Therefore, it takes 1 second for reaching the sound. Suppose if any person is there, then 666 meter distance. Then if we clap, he hears after 2 seconds. If any person is there at a distance of 999.99 meters or 1000 meters or 1 kilometer distance, if he shout or clap, if he hears our sound, he hears after 3 seconds. Similarly, if any aeroplane is flying in the sky, then if it is at 1 kilometer height, what does it take? 1 kilometer height, we hear after 3 seconds. But this Tejas aeroplane flies at a height of minimum 88 kilometers. 8. For 1 kilometer, it takes 3 seconds. 8 kilometers, it is 8 3s are 24 seconds. Means the other people or the army or the people can hear only after 24 seconds. Does it stay after 4, even after 24 seconds? Well, after 24 seconds, it won't stay there. Therefore, it moves few kilometers, maybe 10, 15 kilometers. But by that time, it won't stay there. Then by that time, it won't stay there. Therefore, it cannot stay. Say by that time, it disappears. Therefore, it is known as PVRT. Intentionally, wantedly, some aircrafts and missiles are developed by this technology. Now, next, BrahMos. BrahMos. Second example we are talking about BrahMos. It is a missile. BrahMos is a missile, and it's a joint venture of India and Russia. Indo-Russian joint venture. Indo-Russian joint venture. Russian joint venture. And it's named after Brahmaputra River in India, Moscow in Russia. Brahmaputra River in India, Moscow River in Russia. And range of BrahMos is 290 kilometers. It can be launched from surface to air. So therefore, it is known as cruise missile. All the missiles, those which can be launched into the surface to air, are known as cruise missiles. And the missiles, those which can be launched from surface to surface, are known as ballistic missiles. They go like bar. And the missiles which can be launched from surface to air, into the air, which can be launched into the air, they are known as cruise missiles. Therefore, BrahMos is cruise missile. Its range is 290 kilometers. Can be launched from surface to air. And BrahMos is Indo-Russian joint venture. It's so India and Russia jointly designed this, and its velocity is 2.8 Mach velocity. Velocity of BrahMos is 2.8 Mach velocity. Means BrahMos travels at the rate of 2.8 times the velocity of sound in air. 2.8, and it is the second fastest missile in the world. BrahMos is the second fastest missile in the world. Since it is second fastest missile in the world, and so many countries are on queue for buying it, and it has been internationally marketed by India and Russia, and the name of the project BrahMos International Limited, and the name of the project BrahMos International Limited. So far, India and Russia marketed 70 plus BrahMos missiles. To which countries? To not the countries like Pakistan and China. Terms and conditions are applied. What are the terms and conditions? So the terms and conditions are, the country should not be an enemy country to either India or Russia. It should not be enemy. This is the first condition. Second condition, it may be a friendly country of either of these two countries or both the countries. It may be friend. The third condition is neutral country, neither friend nor enemy. Based on these three conditions, we have been international marketing. BrahMos has been international marketing, and 70 plus BrahMos missiles have been international marketed so far. To which countries? To the countries like Chile, Vietnam, and some other countries we are going on exporting. International marketing this BrahMos. Now, if BrahMos is the second fastest missile in the world, then what is the fastest missile in the world? USA's. It belongs to USA. USA's X-53A. X-53A is the fastest missile in the world with a velocity of 5 Mach. 5. So ours is 2.8. Now, BrahMos hypersonic. Next example, third example we are learning about. First example, Tejas we have learned. Second example, BrahMos. Third example, BrahMos hypersonic. BrahMos hypersonic. Hypersonic means to travel more than 5 Mach. No, it is under development by India and Russia. Under development. It has not come into the market, and its velocity is 7 Mach velocity. It's Indo-Russian joint venture 7 Mach velocity. Suppose and 7 Mach velocity, 7 Mach velocity. It is under development. Under development. Suppose if it comes into the market, then it goes to the first position. But USA is developing another missile with 10 Mach velocity. 10 Mach velocity, USA 10 Mach. Therefore, we remain our second position in the world. And 10 Mach velocity, that is Scramjet X-43. The name of the missile is SCRAM. Scramjet, then X-43. X-43. Scramjet X-43. Scramjet X-43. And with 10 Mach velocity, this is of development. Therefore, we remain our second position in the world. Now, intensity of sound, let us learn about intensity of sound. Intensity of sound. Intensity of sound. The unit for intensity of sound is decibel. Asked in so many competitive examinations, including Group 1, Group 2, and Constable, it was given. Unit for intensity of sound. Decibel. Unit for intensity of sound is decibel. Now, the intensity of sound produced during normal conversation. Normal conversation will be. Conversation means normal talking, normal dialogue. Conversation is about 50 to 60 decibels. 50 to 60 decibels. 50 decibels to 60 decibels. About 50 decibels to 60 decibels is normal conversation. Now, whispering. Whispering will be 25 to 30 decibels. It is clear that half of 50, normal conversation 50 to 60, half of 50 is 25, whereas half of 60 is 60, 30. Therefore, half of normal conversation, half of normal conversation. Therefore, now second hand in wall clock, sound produced by second hand in wall clock, hand in wall clock. It will be 30 decibels. That's why it's not audible in daytime. It may be audible in the night time. Now, based on which thing it is considered, the intensity of sound produced by the grass. Grass is considered to be 0 decibels. Grass. Intensity of sound produced by grass is considered to be 0 decibels. 0 decibels. So, if grass is 0 decibels, then our normal conversation will be 50 to 60, whispering will be then 25 to 30. Then second hand in wall clock will be 30 decibels. Then also we can telephone ringing. Telephone ringing. It will be 60 decibels. Telephone ringing will be 60 decibels. And the intensity of sound should not exceed 85 decibels. Should not exceed 85 decibels. If so, it is known as, according to UN norms, United Nations norms, it should not exceed norms. Should not exceed about 85. Exceed more than, should not exceed more than 85 decibels. 85 decibels should not exist. If so, it is considered to be sound pollution. But in major cities like Hyderabad, it exceeds 85 decibels, 85, 90, 95, 100 decibels. Somewhere in industrial areas also it takes 110 decibels, but it should not exceed 85 decibels according to UN norms. Asked in so many competitive examinations, So the intensity of sound, if so, it is considered to be sound pollution. If it exceeds 85 decibels, then it is considered to be the sound pollution. If so, it is considered to be sound pollution. The intensity of sound exceeds what limit, it is considered to be sound pollution. If the intensity of sound exceeds 85 decibels, then it is considered to be sound pollution. That's why it should not exceed more than 85 decibels, it should not exceed. More than 85 decibels, it should not exceed. Similarly, if the intensity of sound reaches 115 decibels, 115 decibels, 115, then it leads to deaf. Leads to deaf. And human eardrum can withstand up to 120 decibels. Up to 120 decibels. Human eardrum can withstand up to 120 decibels. Means it may break on or after 120 decibels. But thunderbolt also, thunderbolt, 120 decibels. Thunderbolt will be, or thunderbolt or bomb explosion. It will be 120 decibels. Thunderbolt or bomb explosion. Then thunderbolt or bomb explosion will be 120 decibels. The airplane, the intensity of sound produced by aircraft, that is nothing but warplane, aircraft, will be 125 to 130 decibels. Similarly, rocket launching will be 160, 150 to 160. Rocket launch. Rocket launching will be 150 to 160. That's why scientists will be very near, but by seeing only they can operate. They will stay in the glasses, soundproof houses constructed by thicker glasses. By seeing only they can operate, but they will be in the safer houses constructed by thicker glasses, soundproof houses. It will be minimum 150 to 160. Therefore, they will stay in the soundproof glasses. By seeing only they can operate, and outside this rocket launch, rocket will be there, and inside the soundproof houses, the scientists will stay. Now, the largest sound produced among the living beings on the earth, largest sound on the earth, largest sound on the earth will be and 180 decibels among the living beings. Especially blue whales can produce this sound. Blue whales. It's like a whistle-like sound. And for attracting female blue whales, the male blue whales can produce this sound. Only male blue whales can produce the sound for attracting female blue whales. Female blue whales. This is the largest sound produced. Now we are going to start another topic, magnetism. Magnetism. What is magnetism? The property by which the metals can attract with each other is known as magnetism. Property by which metals can attract with each other. Metals attract with each other is known as magnetism. The property by which the metals can attract with each other is magnetism. And magnetite is known as natural magnet. Magnetite is known as natural magnet. Magnetite is known as natural Fe3O4. Magnetite is known as natural magnet Fe3O4. This is natural magnet, which is available in the nature, and it was invented by not by a scientist, by a shepherd, but by a shepherd. Whenever he has gone with his little beings to the forest, and unexpectedly and he was having axe in the hand. He dipped in the water, and along with that axe, whenever he pulled up, and it was he was to apply the strong force for pulling out. Something was stick to it. So some stone was stick to it, and forcefully he lifted out of the water the axe. Along with the axe, the stone has come. That is nothing but magnetite, and forcefully he took out the separated from the axe. That is nothing but magnetite. Fe3O4. Magnetite is Fe3O4. So that is about magnetite, which is natural magnet, which is available in the nature. Natural magnet, which is available in the nature. That is about magnetite, which is available in the nature. Available in the nature. That is about magnetite. Fe3O4, which is known as natural magnet. Now types of magnetic materials. Types of magnetic materials. So magnetic materials are usually three types. First one is diamagnetic materials. Diamagnetic materials. The materials, those which are slightly repelled by strong magnets, are known as diamagnetic materials. The materials, those which are slightly repelled by strong magnets, are known as diamagnetic materials. They are slightly repelled. Slightly means very, very less. Least they are repelled. Slightly repelled. Repelled are known as diamagnetic materials. Since they are slightly repelled, whenever they are brought up near to the strong magnetic field, they move away from the applied magnetic field. They move away from the applied magnetic field. These materials, whenever they are brought up near to the strong magnetic field, they move away, move slowly away from the applied magnetic field. Slowly from the applied magnetic field. Then example for diamagnetic materials. Example for diamagnetic materials. Example. Air is example. Then water. Then hydrogen. Then bismuth. Then diamond. Then mercury. Then gold and alcohol. And also alcohol. All these are diamagnetic materials. Air and water. Air and water are so, and it is easy to remember all these diamagnetic materials. Why? Because here each and every material has its own specific property. They have specific properties. That's why it is easy to remember them. For example, air and water. What is air? Air is essential for all the living beings on the earth, even animal beings, including human beings, and also plant beings. Without air, nothing will be there. Why? Because in the air, oxygen will be there, which is known as breath of life. Air or oxygen is necessary. And water is after air, the essential thing is water for all living beings. Without air and without water, no living beings will be found on the earth. No living beings will be there on the earth. Now then hydrogen. Hydrogen is the lightest gas, lightest element, highly inflammable gas. Then bismuth. We don't know bismuth, and from olden days we are using, even nowadays also we are using. Nowadays also even any brass and bronze vessels, if they break down, if hole is formed for compensating the hole for joining or for repairing we are using this one. Diamond we don't. Diamond is the hardest material among all the elements and costlier among the all ornaments or all metals of the pet. The cost of the diamond may start at few thousands, maybe 30,000 around about, but it varies up to lakhs and crores, hundreds of crores, thousands of crores plus. And gold diamond value is expected to be 40,000 crores plus, more than 40,000 crores. Now, mercury, what is mercury? Is the only metallic element which is liquid state at room temperature. Today, so far, we have 118 elements today. After 118 elements, only 2 elements are in liquid state. They are bromine and mercury. But bromine is non-metal, whereas mercury is a metal. Mercury is a metal, it is an element, it is in liquid state. Therefore, mercury is the only metallic element which is in liquid state at room temperature. Now, gold and alcohol also play a crucial role. Why? Because the human beings are fond of either of these two, interested either in gold or alcohol. That's why they are also playing crucial role. So that's why these are the diamagnetic materials. Now let us think about paramagnetic materials. Second one. There are 3 types of magnetic materials. The second one, paramagnetic materials. Let me take 2 more ones, please. Paramagnetic materials. What are paramagnetic materials? Those which are slightly attracted by magnets. Those which are slightly attracted by magnets are known as paramagnetic materials. Those which are slightly attracted by the magnets are known as the paramagnetic materials. Since they are slightly attracted, whenever they are brought up near to the strong magnetic field, they move slowly towards the applied magnetic field, Suppose here is the paramagnetic material, then paramagnet, if you move towards them, if any strong magnet is there, they move towards, but slowly. Why? Because they are slowly attracted. Now, what are the examples for paramagnetic materials? Example for paramagnetic materials. Example for paramagnetic materials. Oxygen is an example. Oxygen, then copper, then manganese, then aluminum, platinum, then chromium. All these are the paramagnetic materials. They are slightly attracted by the paramagnetic materials. Whenever they are brought up near to a strong magnetic field, they move towards the applied magnetic field. Therefore, they are paramagnetic materials. Next, ferromagnetic materials. Ferromagnetic materials. Ferromagnetic materials. The materials, those which are strongly attracted by magnets, are known as ferromagnetic materials. Those which are strongly attracted by magnets are known as ferromagnetic materials. Strongly attracted. By magnets are known as ferromagnetic materials. So whenever they are brought up near the strong magnetic field, they move rapidly, move fast or rapidly towards the applied magnetic field. They move rapidly. So why? Because they are strongly attracted by magnets. Then example for ferromagnetic materials, example, iron, Fe is an example. Then cobalt, CO is an example. cobalt CO, then cobalt CO, iron cobalt, then nickel Ni, then dysprosium Dy, dysprosium Dy, SPROU dysprosium Dy. Dysprosium is one among the elements. Dysprosium is one among the elements. Dysprosium is one among the elements. It's one among the elements. Therefore, dysprosium. Now, and also gadolinium. GADALONIUM. GADALONIUM. Gadolinium. GD. GD is gadolinium. So that is GADALOU. Then that is about gadolinium. Now all these are the ferromagnetic materials. Then let us make a note. Strong magnets are made up of which material? The strong magnets are made up of alnico. Write in capital letters ALNICO. ALNICO. The strong magnets are made up of which material? Usually the strong magnets are made up of aluminum, nickel and cobalt. They are made up of aluminum, nickel and cobalt. Alnico. And also iron will be there. Aluminum, nickel, cobalt and iron. Okay. With this, we are ending this physics chapter. In the next class, let us start chemistry in the next class. Let us start chemistry in the next class. Okay. Thank you and see you in the next class. Let us start chemistry. Let us start chemistry. Okay. Thank you.